Here we have a wide variety of problems. So these problems can be grouped under toy problems and real world problems. The problems can be grouped under toy problems and real world problems. So if you take the toy problems will be given as a exact description. We have the exact description for the toy problem. Okay, it means that the many researchers can use these problems to compare their performance of their algorithm performance. Okay, so they will be developing different types of algorithms. Yes or no? So to compare the performance of their algorithm, this toy problems will be used because the toy problems will be given the exact description. Okay, and the real world problems does not have um, agreed description. They don't have agreed description. So that is why the formulation of this will be in general. The real world problems formulation will be in general. Okay. Now we'll discuss what are the different types of pi problems we have. So here we have vacuum mold problem and 8 puzzle problem, 8 queen problem. These are the problems comes under pi problems. Okay. First we'll discuss what is vacuum mold problem. So in the vacuum mold problem, we have discussed to define the problem. What are the elements we have to consider? What is the state, initial state, successor function, goal test, and path cost. These are the 5 parameters we have to consider whenever we are defining the problem. Okay. So what are the different states we have? So what are the different possible state? For example, here we are taking only 2 locations. In each location, either dirt is right, dirt may be present or may not present. Okay, so these are the two conditions we are taking. So with this condition, what are the different possible states we have? 2 into 2 square, that is 8 possible states. Because how many locations we are taking? We are taking only 2 locations, and each location will have two possibilities. That is, that location might have dirt, might not have dirt. Okay, so that is why what are the different possibilities here? Totally 8 possible states. Okay. So the initial state. So in this 8 possible state, any state can be initial state. Okay. Then what is the successor function? So this generates the state that result from trying 3 actions. So in the vacuum cleaning agent, what are the actions it can perform? Either it should right, or suck. These are the 3 actions it will be performing. Either performing any one of these action, the what is that? The environment will be going from one state to another state. Is that not? So what is the next state it is moving? It is going by performing these actions left, right, and suck. Okay. So the complete state space is represented here. It is given like this, students. You just see this figure. Okay, see here, this is one state. So this is the another state, second state, third state, fourth state, 5, 6, 7, 8. I told you how many states we have. We have totally 8 states. Okay, so this represents the state space. 8 states represents the 8 states of this vacuum cleaning agent. Okay, and here we have discussed that, for example, this is the initial state. What is the final state? The final state is that there are no dirt in any of the location. This is the final state. It has to reach either this state or this state. Okay. Now, for example, it is in this state. Okay. Now, what are the different actions it can perform? If it takes left, it will be in the same state. Okay. If it takes right, it moves to this state. For example, it takes suck, then it goes to this state. Suck means what? It means the dirt in that location. Okay. So it goes to this state. Okay. Then, for example, it is taking the action called suck, then this is the successor. Say if it is taking the action called left, then it will be the successor. Same state will be the successor. Say if it is taking the action called right, then it will be reaching this state. Okay. So what are the successor states? The same state or this state or this state. These are the successors of the initial state. Okay. So after taking search, then it will be reaching this state. Then what is the action? The correct action it has to take, it has to move to the right. Then it will, what is that? Vacuum cleaning will be moved to the next location, right location. Once it cleans this, okay, then it is reaching the sub, means what? It cleans that. Sub means it cleans that, then it reaching the goal state. Okay. So like that, what are the different, taking different actions? What is the state it is reaching? That is called successor state. Okay. So that is the successor state. Then here the goal test. What is the goal test? The agent checks whether all squares are clean. If all squares are clean, then it is reaching the goal state. Then, so this particular state is called goal test. Then what is the path? For each step cast. So for example, if it is just taking right, okay, it will be moving. So what is that? One step it is taking. So each step cast one here. So what is path cast is number of steps in the path. How many steps it is reaching? For example, it is taking suck here one step, then right second step, then suck again third step. In the third step, it is reaching the goal state. Okay, for example, it is taking right one step, then it is sucking second step, then again left third, then sucking five, third, and then fourth, like this. So number of steps it is taking to reach the goal state is called the path cast. Okay. So in this particular case, what is that here? The state is determined by the agent location and dirt location. Here agent location, where agent is, where is the vacuum cleaner and where is the dirt. Both it is considering. So in this particular state, state is determined by both agent location and dirt location. Okay. Now here we have taken only two locations. Yes or no? So AB. Now in large environment, for example, there are n locations. In that case, how many states we have? N into 2 power n states. Okay, the total number of states will be n into 2 power n states. Okay. So this is the example of vacuum cleaning result. Now we'll take 8 puzzle problem. In 8 puzzle problem, so this is the, for example, start state, initial state. What is the goal state? Goal state is that the puzzle will be designed like this. So you know that 8 puzzle problem will be having 3 cross 3. Okay, 3 cross 3 form, that is there are 9 locations in this, and in that one location will be empty. Okay, so uh, the squares adjacent to this, that is 2, 5, 6, 3, this are adjacent, can move to this empty location. Okay, finally, when we are moving like this, finally it has to reach the state like this. If it is reaching this state, then we say that it is reaching the goal state. Okay. So, what is the state here? The state can be specifies the location of each of 8 tiles and the blank in one of the 9 squares. We have totally 9 squares and we have 8 tiles and one blank in that. So any one of that can be, or there are, okay, all the any possibility of that is the states here. Okay, an initial state usually designed shown like this here. This is the initial state. It is given here in this problem. Okay. Then what is the successor function? So what is the state it is reaching by trying 4 actions? So what are the 4 actions it can take? Left, right, up or down. Either of these actions, if it is trying any of this action, what is the state it is reaching? That is called successor function. Okay. The successor function here, either 2 can move down, that is 1. Either 6 can move left, or 5 can move right. Okay. Then 3 can move up. Okay. These are the 4 successor functions. By performing these actions, what are the states it is reaching? Okay. Those are the successor functions. And what is goal test here? The agent checks whether the state matches the goal configuration shown in the figure. This is the goal configuration given. So the whatever state it is reaching, whether that state is goal configuration state or not, it will be checked. Okay. And path cast in this also same thing. So each step cast here is 1. So what is the path cast? Path cast is the number of steps in the path. The total number of steps it is taken to reach the goal state is called path cast. So this is the 8% problem. So the third problem here is 8 queen problem. The goal of 8 queen problem is that to place the 8 queens on a chessboard such that no queen attacks any other. Okay, no queen attacks any other queen. Okay, like that we have to place the 8